an experiment here. This experiment says, hey, the success rate of corneal transplant surgery is 85%. So an important number. The surgery is performed on 6 patients. Another important number. Question says, hey, construct the binomial distribution. So when we're talking about a binomial distribution, it is a discrete random variable. Discrete random variable. This discrete random variable counts the number of successes in this surgery. So X counts the number of successes. So in the surgery, you might have no successful surgeries, so 0 successes. Or it might be 1 successful surgery, or 2 successful surgeries, or 3, or 4, or 5, and at most 6 successful surgeries. It's a binomial distribution. So let us form the binomial distribution, which is a table. So we use a ruler and have a nice table. Write everything a little bit nicely. There we go. This. So you have random variable X and the probability of that random variable, right? So when we're forming the probability distribution, in this case, we need to use our calculator, right? Let's go over each step together and build this probability distribution, then we can actually visualize this as well. We can use the graph down here as well. So you see what are we doing in this case? Probability distribution for the number of successful surgeries. So let us start. Here we have X. X can be 0, no successful surgeries. What is the probability of no successful surgeries? Turn on your calculator. And since it's a binomial distribution, you're counting each one of these values. So first, go to second, and then vars, and find binomial PDF. What's the number of tries? We have 6 numbers of tries. What's the probability of success? 85%, so 0.85. What is X? The very first X value is 0. So you're going to enter 0. And the probability, wow. Then you see a number like this, it means that you need to move the decimal 5 places to the left-hand side. This exponent here, -5, it means that you need to move the decimal 5 places to the left side. So basically, the probability that X is 0 is 0.0000 and 1. Very small probability, very small. Now I'm going to change it to 1. What if we have 1 successful surgeries? So second vars, go to binomial PDF. The number of tries is 6. The probability of success is 85%. Now you're going to change X value to 1 because this is 1 successful surgeries. So here, calculate the probability. This is going to be again small. You need to move the decimal 4 places to the left. So the probability that X is 1, just 1 successful surgery is going to be 0.00030. And if I round this, 39. Now what if we have 2? You want to know what's the probability that X is 2. It means that we have 2 successful surgeries. We're going to repeat this process. Second bars, go to binomial PDF. The number of tries is 6. Probability of success is fixed. Now your X is going to be 2 because we are finding 2 successful surgeries. And then this is getting a little bit larger. So you have 0.0055. Very good. Or you can just leave it as the same number of decimals as you see here. But in that case, it's going to be 0, 0, 5, 4, and 9. If you repeat this process, the probability of success having 3 successful surgeries is going to be about 0.041, 45, 4 successful surgeries, or it's going to be 0.17618, 5 successful surgeries. It is going to be 0.39933, and finally 6 successful surgeries. The probability that we have 6 successful surgeries is going to be 0.37715. Please note that if you add all of these probabilities together, it must be equal to 100% or 1. But what's the graph look like? So here, the maximum probability is about 40%. So I'm going to have 40% here. It helps to scale it a little bit easier this way. So you have 0, then you have 1, 2, 3. These are X values, 4, 5, and 6. And you're going to use bars to represent these. So this is very small. It's probably going to be a flat bar. The next bar is going to be, this is a small as well. So I'm going to just move it a little bit up. So you see a little bit of difference between these two. Very small difference. This is going to be a little bit up for X equals to 2. Just a little bit. So you see a difference between these small values. And then you're going to have about 4%. So 4% is going to be a little bit up here. And then for 4, you have 17%. Okay, 17%. So this guy goes up here. 17%. And the probability X equals to 5 is 39%. So it's go up near 40%. And the probability that you have exactly 6 successful surgeries, it's going to be 37%. So it's going to be a little bit lower than this guy here, just a little bit. You need to be differentiate between these bars as well. But this is basically the probability distribution and the probability histogram. It's a probability histogram.